Okay, lesson 5.4, we're going to talk about nonlinear systems of equations. We've been looking at linear systems of equations in chapter 5 so far, and now we're going to talk about systems that have one or more nonlinear equations. So in this system right here, you can see that the first equation is linear. It has x to the first power, y to the first power. That means it is linear. The second equation has x squared and y squared. And the way this equation is set up, you can see that it is a circle centered at the origin, because if you look at it, it's x minus 0 quantity squared plus y minus 0 quantity squared is equal to 10 squared. And so that is a circle centered at the origin with radius 10. So that's a circle. And then the first equation is a line. So if we solve this, we could get two intersections because the line could go through the circle. We could get one intersection because the line might be tangent to the circle and just touch it. Or we might not get any solutions because the line may not even come anywhere near the circle. So first of all, with the linear equation, we would isolate y, and we can see that we have a slope of negative 1/7 and a y-intercept of negative 50 over 7. So that is a line. We could go ahead and graph that line. So the y-intercept is negative 50 over 7, which is about 7 1/7 down there. And then if we go over 7 and up or down 1, we can find another point, and that's what that line looks like. And then the circle, as I said, is a circle centered at the origin with radius 10. So that's what that looks like. So there are two intersection points, and we will go ahead and find out what those are. So we're going to use substitution because you cannot use elimination when you have x's in one equation and x squared in the other equation. So we're going to use substitution, but I don't want to substitute that stuff in for y because it's too ugly. So we'll solve for x, and we'll have negative x is equal to 7y plus 50. And so x is going to be negative 7y minus 50. So I'm going to plug that in for x into the second equation. So negative 7y minus 50 quantity squared, and that is plus y squared equals 100. So when I multiply this out, I'm going to get 49y squared minus 700, plus 700y plus 2500 plus y squared equals 100. And then if I add the y squareds on the left, I've got 50 y squared plus 700y. And if I subtract 100 on both sides, I'm going to have plus 2400, and that equals 0. I can factor out 50, and I'll have y squared plus 14y plus 48 is equal to 0, and I can factor that into y plus 6 and y plus 8. So if those things multiplied together give you 0, one of them must be 0. So y could be negative 6, or y could be negative 8. And if I plug those into either equation, I'll plug the negative 6 into that equation right there, and I will have x is equal to 42 minus 50, which is negative 8. And so that would mean that this point right here is negative 6, negative 8. And then if I plug negative 8 in for y, I'll do the same equation again. X equals negative 8 times negative 7 is 56 minus 50, which is 6. And so this point over here is 6, negative 8. So those are the two solutions to this system of equations, and they can be represented with that graph right there. All right, here's another one that involves nonlinear equations. So that first equation is a circle again, and the second equation is half of a parabola. Remember that when you have y equals the square root of x, you're talking about a parabola, but it's only the positive part of it because a square root can't be negative. So we'll solve this one algebraically, and then we'll look at the graph. So we can substitute 3 times the square root of x minus 8 in for y in the first equation. So we're going to have x minus 5 squared plus 3 times the square root of x minus 8, and that is also squared. And then we will multiply all that out. X squared minus 10x plus 25 plus 9 times x minus 8 when you square that, and that equals 25. And then you can add it all up. You'll have x squared minus 10x plus 25 plus 9x minus 72 equals 25, and that's quadratic, so you're going to have to get everything on one side and set it all equal to 0, and then you can factor this into x minus 9, x plus 8, and so the solutions for x here would be 9 or negative 8. If we plug those in to that second equation, y equals 3 times the square root of x minus 8, you're going to get y equals 3 times the square root of 9 minus 8, and that is 3. So that would be one solution would be 9, 3. And then if you plug in negative 8 for x into that equation, you would have y equals 3 times the square root of negative 8 minus 3, minus 8. And that ends up being 3 times 4i, which is 12i. So that is not going to be a solution because we are working with real numbers here. So here is a picture of that graph. You've got the circle, and then you have that half parabola. Okay, this one, again, these are nonlinear, but this time they both have x squared terms. So we can use elimination in this case. We can multiply the second equation by negative 2. And if we do that, we're going to leave the first equation the way it is. And the second equation is going to be negative 2x squared minus 4y squared equals negative 44. And if you add that up, the x's are going to cancel, the x squares are going to cancel, and you'll end up with negative 3y squared equals negative 27. If you divide both sides by negative 3, you get y squared equals 9. And that means that y could be plus or minus 3. And so if you plug in either plus or minus 3 into one of the other equations, you're going to get the same thing, because when you square 3 or negative 3, you're going to get 9. So we're going to plug this into the first equation, so we'll get 2x squared plus 3 squared equals 17. And then you can subtract 9 on both sides and divide by 2. And you're going to take the square root, and x will be plus or minus 2. So all combinations of plus or minus 3 and plus or minus 2 are going to be solutions here, because when you put in 3 for y, you get plus or minus 2 for x. So 3 positive 2 and 3 negative 2 are both solutions. And if you plug in negative 3 for y, you're going to get the same two things, plus or minus 2. So negative 3, negative 2, and negative 3, positive 2 will both be solutions also. So you have 4 solutions. So this one is an ellipse and a hyperbola, and you can see from the graph here already that they don't intersect at all. And when you solve this, you could just subtract the two equations. So you would get 5y squared equals negative 5, and so y squared would be negative 1, which means y would be I, and plus or minus I. And so that is not a real number, and so there are no solutions. Empty set. All right, here's an application of nonlinear equations, systems of nonlinear equations. So you have the perimeter of a television screen is 140 inches, the area is 1,200 square inches. Find the length and width of the screen. So first of all, part A, find the length of and the width. You know that the perimeter is 140, and so that means that 2x plus 2y is 140. 2 times the length plus 2 times the width is the perimeter all the way around. And then also, it tells you that 1,200 square inches is the area, which means that x times y is 1,200. Length times width is area. Now you can solve this system of equations. You can solve for y in the second equation and use substitution. So you're plugging 1,200 over x into the first equation for y, and this is what you get. And then you multiply the whole thing by x to get rid of that denominator. And you end up with the quadratic equation, 2x squared plus 2,400 equals 140x. Get everything on one side, and you will be able to solve that, thankfully, by factoring. And so you can factor out a 2, and you'll have x squared minus 70x plus 1,200 equals 0. And then you can factor that x minus 30 times x minus 40. So there are two possibilities for x. Could be 30 inches or 40 inches for the length. To get y, you can just plug those back into the linear equation, since it doesn't matter either way. So you would have 60 plus 2y equals 140, and then 2y would equal 80, and y would be 40. And if you put in 40 for x, you get 30 for y, obviously. So the dimensions of this TV screen could be 30 by 40 or 40 by 30. Not sure why I circled that, but it could be either one. All right, so we want to find the length of the diagonal. And so that is just the hypotenuse of a right triangle that has length and width, 30 and 40. So it doesn't matter which is which. The diagonal will be the same. So x squared plus y squared is equal to z squared, the diagonal. We could have called it d squared. So 900 plus 1600 is 2500, which is z squared. So z is going to be 50 inches, not 500 inches. Okay, now we're going to talk about inequalities, and inequalities are just where you are looking for a region of the xy plane that satisfies the inequality. It won't be a line or anything, but it will have a border that is either a line or a circle or hyperbola or parabola, whatever. So it will be groups of points that are on either side of some graph. So in this case, you've got a linear inequality. And so you can look at the line that is associated with that, which is just, if I move that 3x to the right side, that'd be negative 2y equals negative 3x plus 6 divided by negative 2. And you have this line. And so that has y-intercept negative 3 and slope 3/2. And it looks like this. Now, we don't want the line, we want the inequality that is here. So if we write that inequality in terms of y, we are going to have y is greater than 3/2 x minus 3. Because when we divide by negative 2 in that situation, we have to flip the sign. So we have this inequality. We don't have y equals 3/2 x minus 3, so we don't want to include the line in our graph. We want to know all the points where y is greater than 3/2 x minus 3, and those points live on one side of the line or the other side of the line. They are all going to be on one side or the other. So we have to figure out which side we need to shade to figure out where all those points are. So the way we do that is we test a point on one side or the other. It doesn't matter which side we choose. I always just pick the easiest point to check. So if we check the point 0, 0 in this inequality, and we plug that in for x and y, we're going to have 0 is greater than 3/2 times 0 minus 3, which tells me that 0 is greater than negative 3. That is a true statement, and so that side of the line is where the points work. If it's 0, 0 works, and it's on that side of the line, then every point on that side of the line will work, and so that is the area that we would shade, be all on that side. Now, we could have chosen a point on the other side of the line to test in our inequality, and it would not have worked. And so we would have known we shouldn't shade that right side, we should shade the left side. I just pick the easiest point to check. Sometimes the graph goes through 0, 0, in which case you cannot check 0, 0. It won't help you. But if it's not going through 0, 0, then you can pick that to check. All right, here's another one. We want to graph the solution set here, and this is for y less than or equal to 3x, and this is also linear, and so we would get y by itself, and we'd have y is less than or equal to 3/4 x, and so that line has its y-intercept at 0, 0, because there is no b here, and then you go up 3 and over 4 to get another point, and you have this line. I'm making a solid line this time because this is less than or equal to 3/4 x, which means I want to include y equals 3/4 x in my graph. That is the line itself. So now we just need to check a point on either side of the line to figure out which side we want to shade. Now, this time, like I was saying, I can't check 0, 0 because it's on the line. So I could check for 4. And so if I do that, I'll have 4 is less than or equal to 3/4 times 4. And that would mean 4 is less than or equal to 3, which is not true. So that side where I checked is wrong. That's not the side I want to shade. I want to shade the other side. So that's what I do. Okay, next one. Graph a solution set of x is less than or equal to -1. That is just a vertical line that goes through -1. And since we have less than or equal to, we want to include the line in our graph. And now we just need to shade the side of the graph where all the x values are less than -1. And of course, that's going to be on the left side of that line. The next one, 3y is greater than 5. You want to get y by itself, and you've got y is greater than 5/3. Y equals 5/3 is going to be a horizontal line that goes through 5/3. And that line is, I should have made that a dotted line because that should not be part of the graph because this is strictly greater than 5/3, not equal to 5/3. So you would want to make that a dotted line. And of course, all the y's that have all the points that have a y-coordinate greater than 5/3 will be above the line. So let me just make that a dotted line. Okay, we want to graph the solution set of this, and you can see right away that this is a circle. So if you rewrite this, it would be x minus 2 quantity squared plus y minus 0 quantity squared. And so that is a circle with its center at 2, 0, and its radius is 3. So we don't want to include the circle, so we're making it dotted because we just want greater than 9. And so we can check a point inside the circle or outside the circle to see where we're going to shade. It'll be either inside the circle or outside the circle. So if I look at that equation with just the greater than sign, so we're trying 0, 0, it's inside the circle. If it works, we will know to shade inside the circle. So let's put that in, 0 minus 2 quantity squared plus 0 squared greater than 9. So that is going to be 4 is greater than 9, which is not true. And so we won't shade inside the circle. We'll shade outside the circle. Okay, here's another one. These are both linear. We're going to have y equals 1/2 x plus 2 for the first one, for the line part of that, the border. And so we can graph that line. It has a y-intercept of 2 and a slope of 1/2, so looks like that. And we will include the line for that equation, or that inequality, because it does have equal to, less than or equal to. So I'm going to go ahead and check where we would shade this. I'm going to pick a point, 0, 0, since it's below the line. And so if I plug that into that first equation, I will get 0 is less than or equal to 0 plus 2, which is 0 is less than 2, which is true. So that side of that line needs to be shaded because, yes, that point does work. So I'm going to shade below the red line. And I'm just going to put arrows here because I don't know which side of the other line I'm going to shade yet. All right, so let's look at the other line. Y equals 3x minus 3 is the border for that one. And so that has a y-intercept of -3 and a slope of 3/1. So that looks like this. And actually, that line is not drawn correctly, but it doesn't really matter for this particular problem. I mean, it's going to look very similar to what it's supposed to look like. It should really be going through the 0.10, but either way, it's still going to be fine. So we'll just multiply through by -1. That means we have to flip the sign. So y is greater than 3x minus 3. If I put 0, 0 in there, I am going to get 0 is greater than 3 times 0 minus 3. 0 is greater than -3. That is true. So that 0, 0 was above the blue line or to the left of the blue line. And so we want to shade that side of the line. So above and to the left of the blue line is where I want to shade there. So I'm shading that area between the two lines. So just check a point. If it works, you shade that side of the line. If it doesn't work, you shade the other side of the line. All right, here's one where we have 3 graphs. And so we have y less than or equal to -x squared plus 4. That is going to be a parabola, going to have its vertex at 4, and it's going to open down. And so I'm going to see, do we shade below the parabola or above the parabola? First of all, 0, 0 is not on the parabola, so I can choose that as my test point. That is inside the parabola or below the parabola. So we're going to check that. Does it work? If we put that into the inequality, 0 is less than or equal to 4, that is true. So we will shade below or inside the parabola. Let's look at the second inequality, which is a line. So negative y is greater than or equal to negative x minus 2. And if we multiply by negative 1, we flip the sign and we have y is less than or equal to x plus 2. And that line has a y-intercept of 2 and a slope of 1. So it looks like this. And now we need to decide if we need to shade above or below that line. So again, we can check 0, 0. Does it work? 0 is less than or equal to 0 plus 2. That is true. So we can shade the side of the line that has that point, 0, 0, which is below the blue line. So we'll put some arrows there so we know that's where we're going to shade below the blue line. And then y greater than negative 5, that line is a vertical or horizontal line. And so we're going to draw that line. We're not going to include the line because this is strictly greater than. So all the points that have a y value greater than negative 5, of course, are going to be above that line. But if you want to think about checking 0, 0, you've got 0 is greater than negative 5, which is true. So you are shading above the green line. So all the points that are above the green line, inside the parabola, and below the blue line are going to be right there. So that is where we shade. So we just have to be careful to go through each shape or line and make sure we know which side to shade and just use arrows to remind ourselves. And then once we're done with all of the different shapes or graphs, we can shade it.